All right, hi everyone. We're gonna start with the mathematical model, but first I just want to talk real quick about the difference between the equation for a line and your mathematical model. Again, this comes right out of your reading packet, so if you're unsure what that is, take a look at all the papers you may have with you. If you end up not having it, you can find it under our class calendar for August 18th, and it's under the Spaghetti Bridge Lab, and it says copy graph reading. Okay, so this is the equation of a line, the slope y-intercept form, or a linear equation, and it's the y equals mx plus b. You also have a handout that shows you how to take this equation and turn it into your mathematical model. The mathematical model comes from this equation. This, I like to sort of call it a template or the format of how to make your mathematical model. A mathematical model compared to this equation, the mathematical model is specific to a graph. For example, this right here, this is a mathematical model, and it came from this equation. And the information you see here, like stretch, the slope times mass plus 3.2 centimeters, that came from this graph right here. So all this information, all those values, the 0.30 centimeters per gram, or the 3.2 centimeters is the y-intercept, the mass, and the stretch. That all came from this graph. But before we were able to put that in, it started off looking like this, and we went forward and we replaced the y for what was on the y-axis, or your dependent variable. We replaced the m with the slope. We used that how to calculate a slope. We used that this equation right here. If you remember in the video before, this is how I calculated the previous slope. That's how I did it. I used the y2 minus y1 over x2 minus x1, right? So that's how I was able to get the slope. And then you have the times x, and the x is just the x variable, and for this graph, the independent variable, or the x variable, is mass, plus b, and b represents the y-intercept, and here is where the line intercepts the y-axis, and it was replaced with plus 3.2 centimeters. It's relatively easy. The only problem that we run into is that kids get mixed up, or students get mixed up, get them confused, one for the other. This is just a generalized equation, a general equation. It is just to show you that your graph, or you use it when you have a linear graph, and this shows a linear graph right here. Okay, let's go through the steps. Let's go through the steps of replacing this equation for a line into your mathematical model, which is this right here. And again, this came right from your reading packet. All right, so the first thing you do is determine the slope and the y-intercept from your graph. So I'm at this point right here. The slope, or m, was calculated, and we did that in the other video, and this is just a kind of short little overview of what I did. I took the equation for slope, which is also known as the rise over run. The equation is y2 minus y1 over x2 minus x1. I put in the the values for those variables. I did the math. I subtracted 18 centimeters minus 6 centimeters over 50 grams minus 10 grams. Ended up with 12 centimeters on the top, 40 grams on the bottom, and then I divided. Remember, there are no fractions in physics, so you would not stop here. You would keep going. You would divide them. Some of you are calling it simplified. That's fine. You can call it that. I don't call it that. I call it finishing off the problem. It's a division problem. There are no fractions in physics. Okay, guys, let's not forget that. Okay, so once you've gone through and you've done the slope, and those two values, or the x1, y1, and the x2, y2, came from these dots right here, these crosses. Once you calculate that, you go on and you decide where your y-intercept is. What is y-intercept? If you're unsure what y-intercept is, I'm going to tell you right now. Y-intercept is where the best fit line or your line intercepts or crosses over the y-axis. And this is your y-axis right here. Okay, this is your y, and this is your x-axis, don't forget. So the y-intercept is just right here where your line intercepts the y-axis, and that ends up being 3.2 centimeters. If I wouldn't have written all over this, it would have been a little bit clearer. So let me kind of increase the size, and you can see that, right? So here is 2.5. This next line here, let me make this really little so I can point it out. This line here is 2.5. This line here is 3.0. This y-intercept goes in between 3.0 and the next line, which is 3.5. So that's how we ended up with 3.2 centimeters. I know that's tricky to see, right? Typically when we're doing this, it's going to be a little bit easier to see, or maybe I'll even give you the y-intercept. So don't be too concerned with that part. You'll usually be able to see it. Anyways, so if I was sort of following along with this and I was replacing everything as I went, at this point right here, our line would look like this, or the y-intercept, or the equation of the line would look like this at this point. If we just calculated the slope and we calculated the y-intercept, we would replace the m and we would replace the b. So we would end up with something like this. Y is equal to 0.30 centimeters per gram times x plus 3.2 centimeters. We're not done yet though. This is not the mathematical model. We're halfway there. So now what we're doing is we're going to substitute the variables from the experiment with the y and with the x. Or I'm sorry, we're going to replace the y and the x with the variables from our experiment. So stretch is S, mass is M. And this is not quite right from this handout. Mass is going to be capital M, because remember, lowercase m is equal to meter. All right, so what do we have here? We have capital S, which represents stretch. We have the slope. We have times m, which really should be capital M, which is mass, plus 3.2 centimeters, which is our y-intercept, which we got from right here. So this right here, which is the same thing right above it, is our final mathematical model. If you see this one right here, they've simply just written out the words instead of leaving S for stretch or M for mass. Either way is fine. It's a little bit easier when you're talking about like distance or displacement or time or velocity or acceleration, just to use the abbreviations. And we'll talk about that later on what the abbreviations are for all those terms. So this is the difference between your mathematical model. This is a mathematical model. I'm going to abbreviate it just math, period, model. And this right here is your equation of a line, or what I like to call EOL, equation of a line. It's your format. It's the template you follow to make that mathematical model. Your Y, your M, your X, your B, those are all specific to the graph that you're concerned with or that you are analyzing. So that's the difference. And I hope you guys, if you have any questions, come see me in class, or if you want, you can even post them in the comment section of the video, because I do check the comments. All right, and I hope this is helpful. The next video, I'm going to go over just a few more things. I'll probably do another example and get you guys understanding this a little bit better. All right.